Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Erina Lara Maharani. You can call me Lara. I'm from Mathematical Education, Class C. Today I will explain about adding and subtracting decimals. 1. Modeling decimals. Decimals models can be used to represent decimals. 1 whole 10 by 10 grid represent 1 or 1.0 tenths or 0.1. One whole grid is made up of 10 rows and 10 columns. Each row or column represent 1 tenth or 0.1. 3. Hundreds or 0.01. One whole grid has 100 small squares. Each square represents 100 or 1.01. Example 1. Find 0.16 plus 0.77 using decimal model. Step 1. Set 0.16 green. Step 2. Set 0.77 blue. The sum is represented by the total set area. So 0.16 plus 0.77 is equal to 0.93. 2. Find 0.52 minus 0.08 using decimal models. Step 1. Set 0.52 green. Step 2. Use X as to cross out 0.08 from the set area. The difference is represented by the amount of set area that does not have an X in it. So 0.52 minus 0.0x is equal to 0.44. Next, representing decimals. Decimals, like whole number, are beset on the number 10. The digits and the position of each digit determine the value of a decimal. The decimal point separates the whole number part of the decimal from the part that is less than 1. Like screen. Next example, write 35.376 in word from 35.376 is 35 and 376,000. Decimal can be written in standard form and expanded form. Is the usual way to write a number. Standard form, expanded form is a sum of the product of each digit and its place value. What from? 1200 turn from 0.12 expanded from 1 times 0.1 plus in bracket plus 2 times 0.01 in bracket. Next, other number system. At the very end of a movie, you'll find the year the movie was made. However, instead of saying the years 2005, you'll usually see it written using Roman numbers as IMV. The Roman number system uses combination of 7 letters to represent numbers. These letters are shown in the table at the right, like a screen. Roman number. All other numbers are a combination of these 7 letters. Several numbers and their Roman numbers are shown below, like screen. Next, the ancient Egyptian number system was very straightforward. A unique symbol representing each decimal place value in the whole number system. The ancient Egyptian numeral system used combination of 7 symbols. These symbols are shown in the table at the right. All other numbers are a combination of these 7 symbols. Several number and ancient Egyptian numerals are shown below. Next, comparing and ordering decimals. Comparing decimal is similar to comparing whole number. You can use place value or a number line to compare decimal. Example, compare decimal. Snowboarding refers to the table beside. Use is greater than or is less than. To compare Denika's score with Jared Thomas' score. Method 1, use place value. Denika's 42.5. First line up the decimal points. Jared Thomas 42.1. Then starting at the left, find the first place digits, compare the digits. Since 5 is greater than 22.5 is greater than 22.1, so Denika's score was higher than Jared Thomas' score. Method 2, use a number line like the screen. Numbers to the right are greater than numbers to the left. Since 42.5 is to the right of 42.1, 22.5 is greater than 42.1. Next, decimal that name the same sum number are called equivalent decimal. Examples are 0.6 and 0.60. When you annex or place zeros to the right of the last digit in a decimal, the value of the decimal does not change. Annexing zeros is useful when ordering a group of decimal. Example, order decimal. Order 15, 14.95, 15.8, and 15.01. From least to greatest. The order from least to greatest is 14.95, 15, 15.01, and 15.8. Next, rounding decimals. You can round decimal just as you round whole numbers. Key concept, round decimal. To round a decimal, first underline the digit to be rounded. Then look at the digits to the right of the place being rounded. If the digit is 4 or less, then underline digit remains the same. If the digit is 5 or greater, add 1 to the underlined digits. Example, round decimals. Round 1.324 to the nearest whole number. On the number line, 1.3 is closer to 1.0 than 2.0. To the nearest whole number, 1.324 rounds to 1.0. Rounding is often used in real-life problems involving money. Example, use rounding to solve a problem. Would a bag of potato chips cost $0.2572 per ounce? How much is this to the nearest 10? To round to the nearest 10, round to the nearest hundredths place. To the nearest tenth, the cost is 0.26 per ounce. Next, estimating sums and difference. To estimate sum and difference of decimal, you can use the same methods you use for whole number. Example, use estimation to solve problem. Estimate the total amount of passengers that travel through Dallas Fort Worth and Los Angeles. Round each number to the nearest 10 for either adding. Like the screen, there are about 130 million passengers. Example, use from an estimation. Estimate 34.6 plus 55.3 using font and estimation. Like screen, using font and estimation 34.6 plus 55.3 is about 89. Example, use clustering. Multiple choice test item use the information in the table to estimate the total number of hours worked in the 4 months. A 210, B 280, C 350, and D 420. Read the test item. The edges are clustered around 70. $72.50 become 70. $68.50 becomes 70. 69.75 becomes 70. 71.75 becomes 70. 70 plus 70 plus 70 plus 70 is equals to 280. Solve the test item multiplication is repeated addition. So a good estimate is 4 times 70 or 280. The answer is B. Next, adding and subtracting decimals. To add or subtract decimal, add or subtract digits in the same place value position. Be sure to line up the 2 points before you add or subtract. Example, at decimal, find the sum of 23.1 and 5.8. Estimate 23.1 plus 5.x becomes 23 plus 6 is equal to 29. The sum of 23.1 and 5.x is 28.9. Example, subtract decimal. Find 5.774 minus 2.371. Estimate 5.774 minus 2.371 becomes 6 minus 2 is equal to 4. So 5.774 minus 2.371 is equal to 3.403. Subtract as with whole number. So 5 0.774 minus 2.371 is equal to 3.403 compared to the estimate. Sometimes it is necessary to nx zeros before you subtract. Example, nx zeros, find 6 minus 2.3x, estimate 6 minus 2.3x becomes 6 minus 2 is equal to 4. So 6 minus 2.3x is equal to 3.62 compared to the estimate. We can also use decimal to evaluate algebraic expression. Example, evaluate an expression. Algebra evaluates x plus y if x is equal to 2.x5 and y is equal to 70.975. X plus y is equal to 2.x5 plus 70.975. Replace x with 2.x5 and y with 70.975. Estimate 2.x5 plus 70.975 becomes 3 plus 18 is equal to 21. The value is 20.825. This value is close to the estimate, so the answer is reasonable. Okay, sorry for my mistake and thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.